Welcome to all of cadets. How are you? It's a very critical moment to you where the COVID-19 has dispersed everywhere in our country. So be safe and sound and stay your home and don't go anywhere from your home. However excellent you are, however better you are, I am Mohammad Ashikur Rahman, lecturer in chemistry at Borishal Cadet College. Today, I am going to start my lesson on second chapter, which is organic chemistry, included to your chemistry second paper, and the topics which you will be taught today, the concept of bond cleavages and free radical in organic molecule. By the end of this lesson, cadets, you will be able to explain about bond cleavage of organic molecule, explain the use of free radicals as attacking agent, and finally you will be able to differentiate between homolytic and heterolytic cleavage. Now, the bond cleavage. The splitting of a chemical bond is known as bond cleavage. There are two types of bond cleavage: homolytic cleavage and heterolytic cleavage. Now, the homolytic cleavage. In homolytic cleavage, the two electrons in the bond are divided equally between the products. Consider the following molecules. It's a general formula of any molecules. When the homolytic cleavage takes place, the two electrons in the bond are divided equally between the products A and B and produces two free radicals known as A free radical and B free radical. In heterolytic cleavage, one atom gets both of the shared electrons. Consider the same molecule here. When the heterolytic cleavage takes place, we get two ions, namely A cations and an anions. Here, one atom gets both of the shared electrons, which is B atom. This is another expression of homolytic cleavage. For your better understanding, I would like to share a video clips. So let's start it.
The two types of popular bond cleavages in organic chemistry are number one, homolytic bond cleavage. And what that simply involves is if you have a bond, let's say, between two atoms A and B, and these right here represent their electrons between them. If the bond breaks in this fashion, where each electron in the bond jumps up on the atom in the left and the right, you end up with something that looks like this. This type of cleavage is called homolytic. Think of homo as same, and notice the products that we're getting the same thing, two radicals. The other type of cleavage that we've seen before in organic chemistry is what's called heterolytic cleavage. That involves the two electrons in the bond jumping up on either the A or B atom. In this case, we have it jumping up on the B. The result of this move looks like this. This is called heterolytic cleavage. Hetero meaning different, which helps us remember that we would get these species as products, two different species, one being A plus, the other one being B minus.
This is the example of homolytic cleavage where an ethane molecule break down and produces two free radical, namely methyl free radical. This is another example of homolytic cleavage. Here, two chlorine free radical is obtained. Cadets, you remind that if each of the free radical contains an unpaired electrons because the bond is cleaved here, that means the free radical contains an unpaired electrons. That's why it doesn't follow the octet rule or duet rule. That means the free radical are electron deficient chemical species. Now, in heterolytic cleavage, we'll know one atom gets both of the shared electrons. Consider the example, which is methyl chloride. When heterolytic cleavage takes place here, two ions, namely methyl free radical and a chlorine anion is produced here. Its name come from the two parts, which is carbon and a positive charge. This is a methyl group, because it contains a carbon atom, and here you see that a positive charge is appeared here. That's why this is known as carbocation. Carbo means carbon and cation means a positive charge, and as this is methyl which contain a carbon atom, that's why its name will be methyl carbocation. Now think about this. In this case, what type of cleavage has taken place? It is confirmed that here each of the two electrons are equally distributed or equally divided between the products. That's why we can say that this cleavage is homolytic. Now consider the following example. What type of cleavage has taken place here? Here we see that the both electrons gets the bromine atoms, because the bromine atoms is a highly electronegative atom than carbon element. So the two shared electrons move towards the bromine atoms and produces a bromide anion and a tertiary carbocation. Boys, why it is known as tertiary carbocation? It will be discussed later. Now, so we can say that this cleavage is heterolytic cleavage. Okay boys, now think it. Is homolysis the same as homolytic cleavage? The answer is yes. The explanation is shown here for your better understanding. Now, do you know how many free radicals are generated during homolytic fission of a neutral molecule with an even number of electrons? Yes, the answer is in this case it produces two free radicals. Do you know what is free radicals? The free radicals is any chemical species which contain an unpaired valence electrons in its outermost energy shell. That means it is not fully octet or duet chemical species. Now, what is generated during the heterolytic bond cleavage in a neutral molecule? Yes, the answer is when heterolytic bond cleavage has taken place, the two ions generated here, namely cation and an anion. Heterolytic or ionic cleavage is the breaking of a covalent bond, where one atom gets both of the shared electrons. Now I will discuss the structure and stability of some free radicals. First of all, classification of free radicals. Free radicals are classified into three types, namely 1 degree or primary free radicals which contain only one R or one alkyl group and two hydrogen atom. Then secondary or 2 degree free radicals which contain 2 R and 1 hydrogen, and finally 3 degree free radicals which contain 3 R or 3 alkyl group but no hydrogen atom here. So we can say that a primary free radicals has one carbon group, that means one alkyl group attached to the carbon bearing an unpaired electron. A secondary free radicals has two carbons or two alkyl groups attached to the carbon bearing an unpaired electron, and a tertiary free radicals has three carbons or three alkyl radicals attached to the carbon bearing an unpaired electron. Now the structure of free radicals. Here we see that a carbon atoms contains three alkyl radicals. This is one alkyl radicals, this is second one, and the third one is here indicated by the by a circle. In this case we see that this free radical contains three alkyl group, so this is called 3 degree alkyl free radical. Here alkyl means it contains alkyl groups, that's why it calls alkyl free radicals. The next one, here we see that two alkyl groups are attached to the carbon atoms with which contain an unpaired free electrons, that's why it's called 2 degree alkyl free radicals. Next we see that the only one alkyl radical it is attached to the carbon atoms bearing an unpaired electrons, so it is known as 1 degree free radical. And finally we will see an example of 0 degree free radicals where no alkyl radicals attached to the carbon atoms which contain an unpaired electrons. Now so it is known as 0 degree free radicals. Now we will discuss the stability of free radicals. First of all, we will consider the 3 degree free radicals. You have to know all alkyl radicals, all alkyl groups is electron donating group or electron releasing group. In 3 degree alkyl free radicals, we see that carbon bears an unpaired electron. That's why it is electron octet incomplete chemical species. That means it is electron deficient carbon. And here, and in case of 2 degree alkyl free radical, we see that here 2 alkyl group present here, and here also the carbon atoms are electron deficient because it contains an unpaired electrons. But in 3 degree alkyl free radicals contains 3 alkyl group. That's why in this case the electron deficient is easily neutralized by 3 alkyl group. But in 2 degree free radical, only 2 alkyl group present here. So in this case the electron deficient of carbon is not easily neutralized by the 2 alkyl group here. So we can say that 3 degree alkyl free radical is more stable than 2 degree alkyl free radical. But when we compared between 2 degree and 1 degree alkyl free radical, in this case we see that 1 degree alkyl free radical contains only 1 alkyl group. That's why when we compared between these, we can say that 2 degree alkyl free radical is more stable than 1 degree free radical, because in 2 degree alkyl free radical the electron deficient carbon is easily neutralized by the 2 alkyl group here rather than 1 degree alkyl free radical. And similarly the 0 degree carbocation is less stable than any other alkyl free radical. So finally we can say that the more alkyl groups there are surrounding the carbon, the more stable it becomes. So we will get the following order of stability here, as 3 degree is more stable than 2 degree, and 2 degree is more stable than 1 degree, and 1 degree is more stable than 0 degree free radical. That means the order will be, the stability order will be 3 degree, 2 degree, 1 degree and 0 degree free radical. Now findings of this lesson. First one, homolytic cleavage produces free radicals. The second one, the heterolytic cleavage produces carbocation. And the third one, the order of stability for free radical is shown here, which is 3 degree, 2 degree, 1 degree and 0 degree. Now the home task for you. First of all, the home task on bond cleavage, which is shown here. And finally we will see a creative question which is